Hi there, I'm Ebrar, and I wanted to show you a React Node app that I've worked on. So let me show you some of the pages from the app. This is the checkout page. So this is where people can come in and enter their payment information and their card information, submit the order to purchase a course. This is the login page. This is where they can log in. And after they log in, they're taken to the dashboard page, which looks something like this. This is where they can see all the courses that they're enrolled in, and they can click one of these courses to go into the learning area. And this is where they can consume the course's content, all the lessons with the videos, the articles, quizzes, and everything else the course has. So now, let me jump into my code editor and let me actually show you the source code and show you the different technologies. So this app is a modern SPA, or a single page application, and it also follows a lot of the cloud native development principles. And it's based on the Jamstack architecture as well, which stands for JavaScript, API, and markup. So in the backend, I'm using Node, like I said, with the Express framework. So this is the main entry point for the server. So this is how the backend is structured with Node and Express. And in the front end, I'm using React with the Next.js framework. So this is Next.js's main app component, and you can see the different pages for Next.js and the different reusable React components that I have here. Although the app currently uses Next.js, I originally used the Create React App toolkit for this app actually. And you'll notice that I'm using a lot of more modern ES6 plus JavaScript syntax. So things like import-export statements, async await, arrow functions, destructuring, all those things. In the back end, as you can see, I'm using all those. And in the front end, the modern JavaScript syntax is actually compiled with Babel to make it more backwards compatible. This is done automatically by Next.js, and Next.js also uses Webpack to bundle everything up as well. And you'll also see that there are plenty of comments in the code to explain the different parts of the code, so following best practices like that to make the code easy to understand. And when it comes to the React side of things, I'm also using a newer React features, so things like hooks and function components instead of class components. And I'm also using Redux. So most of the state is actually managed by React's own use state hook, but some of it is managed by a Redux. I'm using the Redux toolkit here. So Redux manages some of the state there as well. When it comes to the database, I'm using MongoDB, so it's a NoSQL database. This is where the MongoDB connection is made in the backend, and here you can see the different models. I'm using the Mongoose ODM for this. So here you have the schema, the different methods for the different models. As you can see here, these are all the Mongoose MongoDB models. I'm also using TypeScript on both the front end and the back end. So here you can see the different types interfaces that are used. This is for the back end. So this app does have strict type checking, and the types are there are type annotations everywhere. So that's the back end. This is the front end, and you'll see types defined and different interfaces all throughout the application. Now, when it comes to the backend API, the API currently uses GraphQL. So it's a GraphQL API, and it uses Apollo server in the backend. So here you can see the schema with the queries and mutations, the different types and everything. Here are the actual resolvers, which handle the different queries and mutations for the GraphQL API. And on the front end, I'm using Apollo client with React. So if I show you some of the pages, like here, for example, you can see a mutation. I'm using a hook such as the use mutation, use query, use lazy query. So using Apollo client with its caching features on the front end for the GraphQL API. Although the app currently has a GraphQL API, it originally had a RESTful architecture, but I mostly converted it into GraphQL. I'm also using Jest to write a bunch of tests. So I originally used Mocha and Chai, but currently I'm using Jest to write a bunch of tests. Here I have some parallel running tests for, so some of these are unit tests, mostly these are integration tests for the different models, for example, integration tests, and this is for the resolver methods, and I have integration tests for the GraphQL APIs themselves as well. the different API endpoints, the queries and mutations. And I also have a bunch of serial running E2E tests. These are powered using Puppeteer with Chromium. So these are E2E tests, and these run serially. And this is on the back end. On the front end, I actually have, I'm again using Jest to write a bunch of snapshot tests to test the different React components. So you can see these are the different snapshot tests that I have here. And these are just actual snapshots that are generated and stored for these tests. And this app is actually containerized as well with Docker. So the backend API, that is one container. This is the Docker file for that. So this builds the backend API, and the front end React for Next application, that's a different container. So this is the Docker file for that. And in my development environment, I'm using Docker Compose to run this multi-container setup. And in production, I'm currently using Docker Swarm. So I have this Docker stack configuration. This is for production, and this is what so it runs on the Docker Swarm engine in the production server. I'll show you the production server in a minute. But I'm using Git for version control, obviously, and the code is stored in the GitLab repository. And GitLab, I'm also using GitLab's CI/CD features, and I've used it to build a full CI/CD pipeline. I'll show you the configuration. This is this configuration. This is a full CI/CD pipeline which builds the Docker images. It runs all those tests that I just showed you, and then it performs a zero downtime rolling deployment with the rollbacks in case of failure to the production server, authenticating using SSH. So this is like a full continuous integration, continuous delivery and deployment pipeline. I'll actually show you the production server here. So here I'm like logged into the production server with SSH, and if I list all the stacks, so this is like the apps stack that's running right now, and if I list all the services, you'll see that these are the three services. So one is the API, the backend, the web, the front end, and the database, the MongoDB database. So they're running in replicated mode. There are like total of 5 containers here, and this is the specific version that the production the version is running in. So this is like the Docker Swarm cluster, the where it's running. It's a single node cluster, and I'll actually show you the live version of the app as well. So this is the live production version of this application. And this is the version that's actually running live on the web right now. And I'm also using ESLint and Prettier on both the front end and the back end to maintain code quality and style. So ESLint and Prettier to automatically format the code and maintains the style rules and everything. And as far as the styling goes, like for the front end UI, the app is mostly using SCSS or Sass style. So this is like the main style sheet, Sass SCSS syntax style sheet, and it uses a little bit of styled components as well that I have started integrating into the application. So these are some of the styled components, but mostly it's powered by the Sass SCSS style sheet, as you can see here. And the app is mobile responsive as well. And since the app needs to process payments, it uses Stripe for an SCA complaint payment processing and payment flow that I just showed you on the checkout page back there. So yeah, that's about it. I hope I was able to show you a real example of my work and the code that I write and the technologies that I used. And yeah, so thank you for your time and have a great day.